All right, welcome to the lunchtime video, no after work video yesterday, unfortunately. So I don't exactly remember what I was doing. Today is the 5th, so I'm just 10 days away from a major uh, keystone event, and that is my Q&A with Yasmin, who's a representative from Juniper for this exam. A lot of questions to ask, mainly one thing I would really like is like a special discount because of all the extra challenges I'm going to need to take. I've got to take the test wearing a mask. I don't even have a mask. I've just been using uh, old socks that I cut. So I'll have to buy a mask. I'll need to take the test wearing it. So like that's an extra challenge there. I'll need to travel in a plane, which is not recommended. So take an extra risk. So that's going to be my first question: is can we get like a special voucher code or a special discount, maybe even one time free or half price or something like that to make it worth our while, because it's really going to be extra challenging this year, and the CCIE isn't even allowing tests to be taken at all. So if I got to wear a mask for 6 hours, I want some kind of extra incentive to do that. So that's going to be my first question. And then my second question will be, can I even take this thing? I mean, is there going to be a situation where just at the last minute, I'm told I can't take it, and what happens then? Do I get reimbursed? Do I get a voucher to take it at a different time? So I'm hoping that these questions will be brought up by other people, but it might be a pretty sparsely attended Q&A, so I might have to ask them myself. I might need to, I might need to write these questions down and make sure I get everything asked, because it's definitely something that's very stressful for me. I think it's an adventure in some way. It could be fun, but it's definitely, the virus is I'm fairly healthy. I'm fairly young. 35 isn't too bad as far as the virus is concerned. And I'm doing extra things. I'm taking some vitamin D. I'm taking. I used to be taking vitamin C, but like I would like feel really weird in my kidneys, and like I've heard that too much vitamin C can give you kidney stones. So like I drink tea a lot. Like I get vitamin C, so like there's no reason for me to supplement with extra. I think especially if my body's feeling a little weird. So I don't take vitamin C anymore, but I definitely take vitamin D, and then I take 2 antioxidant supplements as well, which is another thing that they say, like, if you take too many antioxidant supplements, you can end up having effects in your body that are pro-oxidant. So I guess I'm just trying to listen to my body, and if it feels weird, change things up. But I'm also following a great YouTube channel, MedCram, and I think the vitamin D is a really good idea. So basically, all I'm saying is I don't think there's huge risk to do this, but there definitely is risk. It's not a normal time. It's not a good idea to do this. And I could end up with the disease. I could end up losing my sense of taste and smell for a year. Rudy Gobert, the NBA player that got it, says he still can't smell, and the doctors will say it's going to come back after a year. So, I mean, I'd rather not lose my sense of smell for a year. Well, it doesn't really matter that much. The thing that really concerns about me is like not being able to walk up a flight of stairs, or like having a chronic cough for the rest of my life. That I'm really concerned about. Okay, so let's see here. Right. So where we left off last, we were looking at IPv6 tunneling, trying to get that to work. So we do have some documentation, but unfortunately, it's really not all that great. So I had to do a Google search. Oops, and I forgot to share my screen. I will do that right now. Okay, so I had to do a Google search in order to find adequate documentation, but I did that and I found this here. Okay, so in this one, they have a topology and they have a configuration they want to apply. So you know what? I think I'm just going to scrap. Well, last video, I think I was debating whether or not I wanted to just scrap what I had and just do this verbatim, or if I wanted to just try to get this to work over my own topology. And actually, that is what I would rather do, is just try to get it to work over my own topology, because I can do show MPLS LSP, and you can see I do have an LSP that is up right now. I am using RSVP for my signaling protocol instead of LDP. And in the previous video, I used LDP tunneling over RSVP, but I have reverted that to just use pure RSVP. So we're not going to have a tunnel over a tunnel. It's going to be much more simplified than that. It might be possible, but yeah, let's read this exam and try to figure out how to get this to work. Okay, so this is tunneling IPv6 traffic over MPLS IPv4 networks. This example shows how to configure the Junos OS to tunnel IPv6 over an MPLS-based IPv4 network. External BGP, Ebgp is used between the customer edge, CE, and provider edge, PE devices. The remote CE devices have different AS numbers for loop detection. Detailed information about the Juniper Network's implementation of IPv6 over MPLS is described in the following drafts. These internet drafts are available on the IETF website. This example shows you how to interconnect two IPv6 networks over okay, there's a grammatical error there. It looks like this example showed you how to connect two IPv6 networks over an IPv4 based network core, giving you the ability to provide IPv6 service without having to upgrade the routers in your core network. Multi-protocol border gateway protocol, Bgp, is configured to exchange routes between the IPv6 networks, and data is tunneled between these IPv6 networks by means of IPv4 based MPLS. In figure 1, routers PE1 and PE2 are dual stack BGP routers, meaning they have both IPv4 and IPv6 stacks. So I believe that's the case with mine here. We've got family INET on the MPLS, family INET 6 on the MPLS interfaces, and then we've got an IPv6 address on loopback 0. The PE routers link the IPv6 networks through the customer edge routers to the IPv4 core network. So this is a bit different because we don't have PE and CE differentiations in my implementation of it here. The CE routers and the PE routers connect through a link layer that can carry IPv6 traffic. The PE routers use IPv6 on the CE router facing interfaces and use IPv4 and MPLS on the core facing interfaces. Note that one of the connected IPv6 networks could be the global IPv6 internet. The two PE routers are linked through an Bgp session using IPv4 addresses. So I believe I have that. Let's check that. Oops, so this is going to be the problem right here. I don't have them hooked up through a IPv4 session. It looks like I tried to set them up with IPv6. So let's fix that and see if we can get it to work over IPv4. All right, so then I'm gonna have to, I can leave that enabled, but yeah, why don't I do that? I'm just gonna leave that enabled, the family inet6, because it doesn't hurt to have multiple families. And I'll just enable family inet unicast as well. Okay, so here's the changes. I'm gonna need to make similar changes on router 6. So this is just to revert the IPv6 configuration, but I'd like to do more than this in this commit. I would like to take care of the IPv4 config as well. So we'll do a edit protocols BGP. Okay, and now we'll do a set local address, and this will be 10.0.0.1. Okay, and now, oops. Oh, you don't need the subnet mask. Now I'll set the neighbor. Okay, so that's all we're going to need. I wonder if did I set a neighbor in the last one? Yeah, I did. Okay. I just, for some reason, didn't have a memory of setting the neighbor. Okay, so everything is good to go. We've got the extra family, but there's nothing wrong with that. So commit and quit and configure the other side, and hopefully we'll have a BGP neighborship go into established. Okay, so yep, we've got the similar configuration. Okay, so yeah, I think that's really all there is to it. We're also not gonna need this anymore, this static route, but we'll take care of that later because that's just about sending a car over the road. Right now, we're worrying about building the road, so trying to send cars over it before it's built is, I think, not the best idea. Okay, so we're still in idle state, but that could be changing very quick. Could also not be changing, which is what it appears to be doing. All right, let's see if I can ping it. And we'll see if I can ping it from the local address used in BGP. Yep, so that's not going to be the issue. So I see the issue. I have Family INET 6 enabled, but I did not enable IPv4 on this side. I only enable it on the other side. Okay, so I think that is the missing piece of the puzzle. Or not. Okay, I do notice. Okay, yep, so here's the tables. So it's still idle. Really not sure what's going on, but that's the point because I'm not sure what's going on in test 2 and I need to solve it. Okay. So let's think about what is required to form a BGP neighborship, and we'll see if we can get a little bit of help from Help Apropos. Okay, so let's get a help on BGP neighbor. So defining peer properties, you can use the neighbor statement to configure BGP peers statically. You can also define peer-specific properties. For more information, see summary of BGP configuration statements. Okay, I'm going to try enabling multipath. Okay, so I'll try that extra knob that makes it so that you can use paths that came from different autonomous systems. All right, so hopefully this is the answer. I have a feeling it is not. No, it is not. Um, so let's keep looking. Instead of matching for neighbor, I think I'm going to match for, so let's match for here because this is going to be an Ebgp neighborship. So this example is configuring external BGP on logical systems with IPv6 interfaces. Perfect, that's exactly what we're doing. Okay, we're actually using IPv4. I wonder if the problem is that there's no router ID, but I thought it could pick it automatically. Not only that, it might actually have one. Let's check. No, it doesn't have one, but I don't think it needs one. Really, I'm not sure. Okay, so instead of matching for neighbor, let's match BGP. Yeah, let's see some examples. Okay, so we're going to have an example for Ebgp. So local address, peer address, and neighbor, those are really the only things that are required. So we've got local address, peer AS, and neighbor. So yeah, I think everything's good to go. Let's see if there's any help for multipath. Okay, so I've defined the policy. Now I'm going to need to apply it. So I'll look at my instructions again. Okay, so I got to apply it to the forwarding table. Let me just get this printed out more recently. Oops. There we go. Forwarding sandbox, that's not what I need. I need, let's see here, it's going to be up here. It's going to be edit forwarding table export. Oops. Or maybe it's going to be set. Oh, forwarding table. All right, so that's not going to work. Ah, so it looks like it's under routing options. Ah, perfect. This is a really good lesson, assuming this is the answer. But I have done a proof of concept that the help apropos method is going to be really effective. The one I'm using now, and not the one where it requires Python scripting. All right, but unfortunately that was not the answer. So I'm going to need to keep looking. Why is it not working? Like the pings are fine. What else does it need? Maybe it needs multi-hop. I guess I'll try it. I'll try, I'll roll back the configuration I made before. What happens if I roll back 3? Okay, what about 4? Oh, right. So, okay, so everything's rolled back. This is a pulse oximeter, in case anyone knows. It just shines a laser light through your finger. I like to just check my oxidation level every once in a while. If I ever am symptomatic for COVID-19, it would be important to have one of these, and I figured to just buy it before there becomes a high demand for it, and I can't get one. They're not super expensive. But anyways, keeping focused, you can see how easily my focus wanders, unfortunately. Let's configure the multi-hop now. Yes, so that was it. It required multi-hop, and that makes sense, I think. Let's read the thing on multi-hop and get a better sense of why that was required. Okay, example, configuring Ebgp multi-hop sessions. This example shows how to configure blah, 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 blah. Overview, the configuration to enable Ebgp sessions requires connectivity between the two Ebgp peers. This example uses static routes to provide connectivity between the devices. Unlike directly connected Ebgp sessions in which physical address are typically used in the BGP statements, you must use loopback interface addresses for multi-hop Ebgp by specifying the loopback interface. Oh, okay, now it's all coming back to me. So I wouldn't have needed multi-hop if I had used a physical interface. Which is what you're more meant to do for BGP. You're meant to use the physical interfaces typically. So if you want to do a special configuration like the one I did, where the connection is on a loopback interface and you're not specifying which physical interface to use, and it's got to decide which one to use, you need that special multi-hop. So it's multi-hop configuration. So it's going to be different from multi-path. Let's see what multi-path is. But it's all coming back to me now. I covered this in many previous videos that if you have an Ebgp session and it's loopback to loopback, you're going to need that multi-hop statement. So multi-path, yeah, would be for, so multi-hop is for the road. In order to build that adjacency, you'll need multi-hop enabled if your adjacency is on a loopback and over multiple interfaces. But multi-path is for sending cars along that road. It's for load balancing the traffic sent over that connection that you formed with multi-path. So I don't think we're going to need multi-path because it doesn't matter to have yeah. So you can see here we're going to have two next hops. We won't need to load balance traffic, so it's okay that just one path is chosen. Okay, but now the neighborship is established. So let's take a look at IPv6 tunneling. Okay, so let's go down to the verification steps. Yep, and now try to ping between the loopback IPv6 addresses. Oops, you don't need the subnet mask. Oops, so it looks like it can't ping. So we'll need to do some more T-shooting. And of course it can't, because Well, let's just do a show route. Yeah, and you can see here they did not need the multi-hop statement. That's because in their topology, they're forming a neighborship between physical interfaces. Actually, I think they're forming it from here to here, but regardless of where they are, which routers they're forming it from, they're going to be forming it from interfaces on those routers instead of loopback interfaces the way I was doing it. Okay, so I think I'm going to expand this policy here, and I'm just going to have it include connected routes as well as static routes. Okay, and I'll do that on the other side as well. Oops, and in Juniper, connected routes are called direct routes. And then there's also local routes. But I think in the actual table, they all are called, nope, they're called direct as well. Okay, so let's see if we've got some extra routes. Nope, we still don't have the routes properly through. And why is that? Ah, man, this is rough. But that's the point. Might as well suffer and struggle through it now instead of on the test, because that's when it counts on the test. Okay, so it looks like I've got some extra statements. Oh yeah, I have an extra family MPLS on the loopback 0 here that I don't on there. I'm going to add that and see if that makes a difference. Okay, and then we'll do some verification commands. Hopefully that's all the difference that was required. Nope, so I'm expecting to see 1001 learned as a BGP route. Yeah, and that would prove that IPv6 was tunneled over IPv4, over an IPv4 MPLS tunnel. But that is clearly not happening right now. It's going to take some more doing. We've got plenty of OSPF routes. We're just missing BGP routes. So I wonder if I have a Bgp export policy that is proper. So here's my export policy from protocol static, direct, to protocol Bgp. I wonder if I need one for IPv6 specifically. Oops. And it's not going to be set, it's going to be edit because I need to go into the hierarchy. So set from rib inet 6.0 protocol direct, and then protocol static, set to rib, set to BGP. Oops, protocol BGP. Okay, I think this is the missing piece of the puzzle. Let's go over to the other side and add it. Shoot, okay, well, I'm gonna take a quick break and come back. Sometimes that helps anyway when it comes to an issue like this. So it'll just be really short, but I will be back soon. All right, so sometimes the solution to a problem is just a 5-minute break away. So mine was probably 30 seconds, but hopefully that will be enough. So we still aren't getting the routes. I think I was on the right track though. So yeah, so I do think I needed to include this statement here. Let's take a look at that. Okay, so these are all the ones that are going to be sent to protocol BGP. Yeah, but that's clearly not happening right now, but that is what we want to get to happen. Okay, so let's go back here and see if the from statement needs to be changed. Okay, I'm just wondering if there's like the protocol. I mean, I'm pretty sure it's going to be from rib inet 6.0. Like I thought that was going to be the missing piece of the puzzle. Okay, I don't know why that didn't make it on there before. Oh, it still didn't make it on there for some reason. I mean, I can remove those other statements. Protocol direct, let's see here. Now it's going to be protocol static as well. Okay, so let's see if that's different. Okay, so it looks like these protocols are not dependent on the rib table. Okay. Oh, and I'm almost out of time. I don't have a meeting right away, so I can go until 1 today. But let's see here. So, why is this not working? Let me know in the comments. God. Oh, is that it? Let me try that. Okay, so we're good to go. Now we're going to need to add the same thing to the other side. But the good news is we might be able to do a check, and that is show routes, protocol BGP advertising protocol, and then it's going to be to our neighbor, which is 6. Oh. So unfortunately that was not the problem because we're still not advertising anything. So the problem was with my policy statement. Let's take a look at what it is. So I don't need, so I actually thought this when I was making it. I'm like, wait, does that need a to or not? I didn't say it out loud, but that's what was going through my head. So you don't need a to statement, you just need a from statement, because all you're going to do is match the traffic and then say it's acceptable, and then you'll apply it. If it's accepted, then you'll send it out through BGP. You don't need to send it to BGP. That's done automatically by having that applied under here. So yeah, I mean, I think this is good enough to end the video on. You can see I've got through BGP the route on the loop back from the other side, and I've also got the static route, so everything's working great. As one final thing, in the last 3 minutes that I have, I would like to remove that tunneling statement and see what kind of a difference it makes. Okay, so we're just going to move it from one side, remove it from one side, and then we'll go and we'll look at the table again. So let's do show route receive protocol BGP 10.0.0.1. And then we'll do a show route and see if those routes disappeared. Yep, so they disappeared instantly. Let's do a rollback one and see them come back. So it took them a little bit, but there they are. So yeah, learned a lot in this video. Learned a good refresher about BGP multi-hop, a really good and well-needed refresher on export policies for BGP, and then of course we learned the initial thing that we were meant to learn, which is IPv6 tunneling. So I'm going to put this down here and then change this because this is video 2. But this is going to be the last video in this topic. I think I did it justice. So the next video will be on RSVP signaling. All right, so thanks for watching, and I'll see you in the next one.